Please let me know if you see the background.
Yes, we can.
That's great.
Yeah, number of people joining have really jumped.
Mm-hmm. And Ritesh, you are a host now.
Okay. I don't see. Oh, yeah, I see the polls, right? Perfect. Yeah, I think we've got 40 people, so we can start this off. Good evening, everyone. Great to see you here. We've got now about 40 people joining, and this is going to be a really interesting topic that we are looking to discuss specifically with the region that we're in, reliable solar PV structures, and we've got a really good panel here. Sadly enough, Dinesh will not be joining us due to some personal issues, but we've got Hans, Elena, Finn, and myself. Just some background. I am from the drone base. I'm from Drone Base, where we do intelligent imaging. But prior to Drone Base, about 4 or 5 months ago, I used to lead the global BD for Scorpius trackers. We've done projects in Saudi. We've done projects in India and Lebanon, Japan for trackers. And before that, I have my advisory. I'm leaving it to the panelists. So Hans, you want to go next?
Yeah, hi to all, and thank you to have the chance to talk about the latest development. Yes, I'm in solar business since 12 years, and I did some gigawatt projects in the region, and I'm the vice president of Next Tracker here, and I'm really happy to show what we are doing in the background in product management, in quality and standard. And yeah, we already installed near 4 gigawatt in Africa and India and the Middle East region as Next Tracker. And yeah, it's very important to talk about the latest development and to talk about the large size modules in this session today.
Thanks, Hans. Elena, you want to go next?
Hello, everyone. Thank you for inviting me to participate in this interesting webinar together with the other experts. I'm Elena Ortiz, working as a project manager for renewables advisory in UL. I'm based in Dubai. My background is mechanical engineer, and I have a master's degree in energy engineering from the University of Oviedo in Spain. I have 10 years of experience in the solar industry, and I spent more than 5 years working at site in the Middle East. I have been working at the main global solar energy companies before joining UL as Abengoa, Masdar, and Acciona. And I have been working in several projects completing more than 2 gigawatts of solar energy. I started working as a mechanical engineer for CSP and PV projects in Spain, calculating the wind loss for the solar structures through simulations and real wind tunnels. And after this role, I moved to UAE, where I have performed different roles at the bigger solar plants of Dubai. I have experience working as a site mechanical supervisor and quality coordination, operation and maintenance engineer, and project manager. And I have a strong experience on the construction, quality, and commissioning aspects of the solar projects. Thank you.
Yeah, that's amazing, Elena. So Finn, you want to go ahead?
Yes. Good afternoon, everyone. This is Finn from Untitled Solar. I'm responsible for APAC and Africa region. And I'm based in Shanghai. I joined Untitled around 3 years. Familiar with the solar mounting structures and trackers. It's a great honor to be here with you to attend this webinar and talking about the structure and tracker topics. Yeah.
Yeah, thanks, Finn, for that. Just some background on the webinar. What we have seen over the last couple of years with the new bifacial modules come in and with higher efficiencies, you've seen the square meters, the area of each module increase, both in width and in length. In the past, we've had a lot of design optimizations, design management in managing modules that were like 1.5 meters, 2 meters. Now modules have reached 2.3, 2.4, and the square meter area is increasing. Now, as we deploy such large size modules, 600 watt peak, up to the 450 watt peak, they were within our already tried and tested. Now 450, 500 onwards, there's been a large area coverage, and we've seen a lot of focus going on saving of BOS. So the modules are becoming larger, even though the efficiency isn't increasing as much as it used to before. And which is why we felt this seminar had a lot of value for everyone, wherein we could actually figure out and discuss where it is going and how do we manage this large module format both into the entire ecosystem, and how we make sure that things happen the way that they're supposed to, since the solar industry is actually an engineering industry, and which is what we're looking to focus here. So I am going to start off with the standardization. I think the first thing that we're looking at is the design standardization from solar PV structure design. What we've seen over the last few years is that there are some standards, but they're not applied globally. We need to make sure that as the solar domain increases, the vertical increases, we need to standardize and deliver a standard quality across the entire board. So I'm just going to put up a poll, and then we're going to take that question. All right, so I've just launched this poll. I'm giving everyone like a couple of minutes where this is a question that I think everybody would be interested in answering. Yeah, the questions and answers are coming in.
Mhm.
We've got about 55% answered. %. It's about a minute, so let's give it about another 30 seconds or so more. Joining a little late, welcome everyone. So we look forward to your questions. Please feel free to put them in the chat, and we will take them towards the end of the webinar. Okay, and this poll is turning out to be pretty interesting. I'll just launch it in about 20 seconds. I think almost everyone has answered, so I'm going to end the poll now. It's almost 2 minutes. So panelists, you can see the poll, and it's quite interesting because it should be left to the designers. is 17% and no. So if you see the yes is 57, it's not an overwhelming majority saying that yes, there should be a standardized design. Let's figure that out. Maybe that's a good point to start with. So who wants to take this? Hans, Elena, who wants to start on this?
Yeah, maybe let me start from a tracker perspective. There's no good or bad answer, that's clear, but it's an answer which I really value because look what we are doing from the BOS design, if it's a fixed tilt or a tracker. So we connecting the soil with the panel. I mean, it's a piece of steel. And we had, let's say, a de facto standard. Yeah, we have a corrosion standard. We had wind design. We have the standard European and American standards applied. But nevertheless, you know, it's very important to reach the lowest cost and the best optimized structure and so on. So and therefore, I think a introduced or common regulation or standard is really very positive, and I can really support this. You know, there are some big IPPs here in the MENA region. They have a third party auditors, and this is also the pro forma standard. But it's much better to have a common standard for all of us, for the suppliers, for the sub-suppliers, and at the end for the project developer. Yeah, I think it's a more transparent and more fair system.
Yes, I agree with you completely. Alina, you've got any point on that?
I agree with Hans. I think it's a topic that we need to work more to create standards that for everyone to follow and to put all together and agree. But it's a discussion that is ongoing, and I think we should put more efforts on the standardizations for the structure.
Right. And Finn, you have a point on that?
Yes, I think it should be left to the designers because at present most areas are use different standards now, and mainly because the climate conditions of these project sites are different. Some areas use European standards, some areas use American standards. It's just very difficult to unify the design standards in a short period of time. And so I think it should be left to the designers, to customize the structure and the trackers according to the project requirements.
Okay, that's an interesting viewpoint. My viewpoint on this is that I think a standard would be beneficial. Now, solar is almost a decade, more than a decade. Solar PV, we've got more than a terawatt installed. So my feeling is that we need to make sure that there is a standard. Obviously, as the region goes, you will need to move it around. But if you move the standard around slightly, the idea is that you can compare apple to apple. What's currently happening in the industry right now is that you have designers coming up with maybe some things which might not really match, and you cannot do an apple to apple comparison across the industry. So what tends to happen there is that there might be areas which need to be focused on, which might not be focused on. So my perspective, I mean, that's my opinion, is that we need to have a standard. I think a lot of people are looking for that. It should be left to the designer. Yes, there are some points for leaving it to the designers, but I think once you have the standard, and then you can keep some minor points or something which can be left to the designers. Yeah, Hans, you have something?
Yeah, I'd like to add one thing. You just mentioned that we are more than a decade working here, and you may recap that a lot of people saying, hey, we are starting here, we have to learn. But in fact, I built the first projects here in the region with Mazda in 2011, 2012. So we had enough time. And of course, 2015, 16 was, 14 was not so busy, but now we're seeing 10 gigawatt coming in the region. Yeah. So this is really the one point. The second point is, I mean, everyone knows that we are already, if it's here in the region or it's in Atacama or wherever, we can handle now from the tracker point of view, we can handle temperature, the motors, the bearing, everything. Yeah, this is not longer a big point. The environment, yeah, we can go to up C4, even here, you know, it's now requested maybe C5, and this goes along with the design life. the dust and the sand and the soil. Yeah, I mean, and last but not least, the wind design. So this is everything known, but it's different interpreted. Still for the big deals here, and this calls, from my point of view, for a more standard standards. Yeah.
Yeah, thanks for that, Hans. I'm also going to, since we are now almost 15 minutes into, I'm going to just request everybody to reply on this poll, which location are you from, so that we can understand where people are coming in from. So I'm just putting this up there. We've got 86 people. Appreciate if everybody can. Right, we've got 70% already people already answering. It looks like this is a global topic because we've got others also, about 20-30% from outside the GCC is what I can see. Right, I think 80% people. So we've now hit 90 participants on the webinar, which is a decent number. So welcome everyone, the guys who have joined, people who have joined late. I'm going to give it another 10 seconds before I close this out. So people who haven't voted, please do, so we can understand. Okay, then I'm going to end this. Yeah. So welcome everyone. It looks like we've got 30% from outside and 30% from UAE and Bahrain, Oman, Qatar, Kuwait. That's a decent blend. And we've got Saudi Arabia as well. That's also pretty good. So thanks everyone. And we just have one more poll so we can understand the background. So they're doing this so that we can understand where everyone is coming from. So thank you for that, Paul. Can you just reply to this part of it as well? So while that is happening, I think what are the, so currently with all the installations in the GCC region, what are the major problems that we are having, Alina? You want to take that question?
Yes, well, in the Middle East, what we need to consider when we design the solar plants is that they are usually based in the desert areas. So whether it's a lot of sand plus the humidity, especially in the areas close to the coast, where the humidity can reach 70 to 85% in summer. So the cleaning of the modules needs to be done every 10 days in some locations. So the frequency of cleaning is an important factor to be considered when designing the structure for Middle East. And we need to ensure that the structure will allow us to use an adequate system of cleaning as the robots. And we need to be very careful in limiting the constraints that can interfere in the use of the specific system of cleaning that we will use. So it's always better to consider robots during the design time with the required alignment of the modules and tracker than later on to have to adapt the structure for that. And in addition, the distance between the rods need to be enough to facilitate the circulation of the cleaning material from one rod to another. I think this is an important factor, key factor here in Middle East, the cleaning. It's much more frequent than in other areas in other regions.
Yeah. Right. Yeah, I think that cleaning is definitely a very key point. And something that I saw maybe in 2018, 19, we were doing something in Mexico. And all the designs, I mean, you talk to all the top EPCs, they were saying we'll do it manually, which is quite surprising because you're talking about 200 megawatt, 300 megawatt plants. And they were saying, no, labor is cheap. And then I guess COVID came in and all that sort of disappeared. That labor is cheap, oh, we'll get it clean. But you have to take into account, you've got to build for the future. You've got to build for a plant which is 25 years. You've got to build for eventualities. What was happening, I think, was that looking based on the price pressures, a lot of optimization was happening, which maybe didn't play out in the long run. So that is definitely a point. So before I move on to Finn for the same question, I'm just going to end this poll. So just so that everyone knows, we have EPCs, service providers, and consultants amongst the majority. I guess it's always interesting for them to know about the design and how things need to be. So this is great. So Finn.
Yes, I agree with Elena. I think the application of cleaning robots is very important in Middle East. And one of the reasons is because of the sandstorm weather. The sand covering the surface of the models that can affect the generation rate of the models. The practical application is to build a bridge between the the structures part, so that a cleaning robot can clean all the trackers in the same row, and I think it can help to reduce the number of the cleaning robots used. And also the system can be set to automatically cleaning at the regular time every day to increase the power generation of the trackers. I think it can also be connected to a SCADA data collection. When the system recognizes that the sandstorm weather stop, also the system goes to the same angle, then the cleaning robots will run to clean the tracker surface.
Right, great. So I think my question more is around robotics is definitely one important point, but the question is more around what is it that we have seen that needs to be improved? We've now installed, I think, between 5 to 10 gigawatts in the GCC and more, I think. So what is it? Is this only robots that are the issue? Is there some areas of improvement, or do we have it down perfect? Hans, what do you think?
Yeah. So first of all, let me respond to Finn. So it's not only the sandstorm, and we now know after, let's say, 10 years doing solar in the region, that it's really, let's say the losses is around 7.3% when you clean it every day or every second day. When you even have the cleaning every week or every second week, you can have losses between 3 and 4% because of the soiling. And this has nothing to do with the sandstorm. And you're right. I don't believe that we in this region have already installed 5 gigawatt on cleaning robots. So we have now in the projects in Sudair, in Sakaka, we have installed, give me another example, 900 megawatt in Deva, and we installed one automatic robot cleaning, and it goes 1.2 kilometer, 1.2 kilometer in one direction. So the challenges are two things. The one thing is on the CapEx side means you have to consider a certain amount of structures, yeah, and of ancillaries, yeah. So this is maybe it's some binders, or it's a bridge, and you need a docking station in the front, and you need a reverse station at the end. So this is something which is common and it's known. So you have to consider this in the CapEx phase. But then you need also a robot cleaning which is able to go, let's say, 1.2 kilometer in one way, and then reverse the other 1.2 kilometer. Yeah, and so we have a lot of so as next trigger a test station in Fremont, and we have now certified 4 of the tier 1 automatic robot cleaning systems. We have another 4 in the queue. And we can immediately offer also our tracker together with a full automated, tested and certified robot cleaning system. So I think this is really very important that we take the headache away from our customers, saying, okay, we have a system which fits together. Yeah, because you have to know the bridges. And by the way, the row-to-row bridge, yeah, we started with plus minus 30 degrees tolerance, but we now have a flexible row-to-row bridge of plus minus 60 degrees. So only in case if 2 triggers are not aligned, yeah, because later on you cannot send out people to maintain this. So these are smaller things, and then the other thing is the cleaning robot. The weight is very important, yeah, and the deflection, and this has to be tested. And they are involved. It's a tracker, it's the robot cleaning itself, and it's the module supplier at the end. It has to be accepted and also approved by third party and the owner's engineer. So this is the world I know, and we did it now here for, let's say, for 2 gigawatt, but it's coming, and I think it became a standard that it's a must that you have a daily cleaning of the module row by row.
Right. Thanks for that, Hans. I think one of the questions that I have is, due to the land in Middle East, and this is for Elena, what do you think should be considered when designing a structure?
Well, most of the solar plants in the Middle East are placed in desert areas. So where are the dunes? So with different slopes. So this type of field requires a lot of civil works to be prepared for the installation of the solar plant if you want to have a flat area. So when we are designing the structures, we should consider the slope of the terrain. North to south, we have the limitation with the dry line of the structures. East to west, we have less limitation as there is no dry line. So of course, these works can increase the price. Also in terms of piling of the specific piles that we will use in the dunes areas, for example, that usually are longer, but longer piles means more steel and more cost. So we should consider this, that there will be prep civil works, that it will increase the cost if we want to have a flat terrain. Otherwise, we will have slopes, and the structure need to be designed for these slopes, long piles, and basically this, then the humidity that we are considering for the maintenance, that we need to do more cleaning and everything, is also affected for the structure in terms of corrosion. So we need to design the structures that they are adapted to this specific weather in the Middle East.
Great. So one of my questions is, now I think a lot of plants have been installed with C3 and C4. I mean, is C3 sufficient? Is there, or are we need to move to C4, C5, given the kind of conditions that we have? So you want to take that?
May I answer? Yeah. First of all, I think, Elena, you are right. The surface, yeah, it's very important. But because if you look to Sudea, if you look to Sakaka or now Deva 5, they did a lot of civil works, because otherwise you have to get rid of the upper layer of the sand. So this is the reason. When you go to Jordan, you really have a underlays system, and you need what we have, the XDR system, or you need a tracker who is able to follow the surface. This is one thing. The most important topic is, in fact, Ritesh, it's the corrosion, yeah? And we cannot say C3, C4, or not C5. So we do a very extensive corrosion evaluation for each project at the beginning. So I can tell you, so we have a full map from Saudi Arabia and from the Gulf region. We know that Zweihan was C3, we have Qatar, Al-Qasar was C4, we have even now C5 in some projects in the Red Sea, which is for a tracker supplier, it's a nightmare. Yeah, and at the same time, C5 with a longer lifetime. So this is something which is very hard to achieve. And you know, there are only 1 or 2 steel grades in the market we have to use. Otherwise, we cannot comply to this high corrosion level. So this is really very important that everyone checks the corrosion very seriously at the beginning. We do a double check, then maybe a third party, and then we have to stick to the findings. Otherwise, you know, there were some projects in Morocco, wherever, that was a nightmare. And we cannot allow that maybe you go with a C3, which is a cheaper steel. Yes, but when it's at the end, the high C4, then everyone has a big problem and get in trouble. Yeah, so this is really very important. And it's not only the piers, it's not only the tubes. You have to see that it's also for the bits and bytes, for the washers, and for the connectors between different steel grades and aluminum. So you have to be very serious when you talk about high C4 or C5.
Absolutely, absolutely. Finn, you have something to add?
Yes, I think, yes, I agree, both of you. Our correlation issue is the primary problem in Gulf area. And for the structure and tracker manufacturer, I think all of them will check the historical weather conditions based on the coordinates of the project site, and to see the weather condition. And generally speaking, we will decide the surface, the coating, the surface coating thickness of the trackers based on the condition of the weather. Yeah.
Okay, understood. So
May I just add one point, Ritesh, because to Finn, it's not only the thickness of the coating, because you know, we have 3 types of different steel. We have the strip coated, let's say G90, G210, American standard, or you have the zinc magnesium coming from South Korea or from Europe. And they have, let's say, they can upgrade from C2, C3, C4, and even C5. Yeah. So this is available on the market, and this is available for everyone. But then it's not only the thickness of the zinc, magnesium, or the pure zinc. Let's say to 40 microns or 35 microns. It's really also the alloy on the kind of steel and the surface treatment you are using. Yeah. This is very important.
Absolutely,
Yeah,
I
I
agree
agree.
100%. Yes,
Yeah.
definitely. And while we're moving into the next segue, what I need, putting a poll out there on 2P versus 1P. I think this is going to be the future, and this is over the last 2-3 years. 2P has come in. 2P has had a number of issues as well, and then we've seen 1P. I mean, we've had manufacturers, utilities going for 1P and 2P. So I wanted to understand, get a feel of where our audience is, and where do you feel? Do you feel 2P is a success, or do you feel 1P needs to continue, or again, should we leave it? I'm launching that poll right now. So please do answer that. While the poll is being answered, I think one of the things that's now happening is because of the size of the modules, the way that they have increased the square meter area. My question to Hans is what is the new developments? What is happening in supporting these modules? Because now they've got a longer length, you've got more flex coming in, you've got more eccentric loading, you've got a lot of things. And when you put robots on top of them, again, that's going to really bend the entire panel. So what's happening in the industry right now, or what's happening by each manufacturer that they're taking care of these?
Yeah, first of all, I like to explain again that the design load increases quadratically with the wind pressure and the size of the module. That means when you double the size, you have 4 times more pressure on the module. And this is why we have a 2 in-portrait solution at Gemini, and we have the 1 in-portrait. When it comes to the 210 modules, we were happy because we said, okay, it's a 1 in portrait tracker, it's a single axis tracker, we put it on and everything is fine. And at the end, I mean, the expectation from the BOS was maybe 15 to 20% a benefit. Yeah, because of savings in structure, because of when you have a 100 megawatt project, you need less structure, so you can save some money. And then when we adapted everything at the first time, we were a little bit shocked because there were zero benefit in the BOS because of the large modules. And then we were working very hard. So what we did, we increased the length of the tracker. So first of all, we had to increase the thickness, we had to increase the piers, we had to increase the rails in the thickness, and even we have different lengths of the rails, so 400 millimeter, 500, 600, and so on. And we did have a lot of tests on this. But at the end, it's easy to deal with the large size modules when you have a one in-portrait tracker, but it's not easy to achieve a benefit. So that was maybe 2 years ago. Now we really have a great benefit. So we going for an extended tracker, so for longer tracker, we could reduce the post by 6 to 8%. We could reduce the motors and the cabling. So at the end, I think it's around 50-60% of the benefit we can give back to the customer. So this is what we did. So that means we have a stronger material, we have a redesign, and of course we did very extensive wind tunnel tests, yeah? And we optimized also the inner sections and the outer sections, and even we developed a tracker, we call it a hybrid tracker. So which is in the north or south, the one half is an outer section, the other half is an inner section. So that means we have really to do anything to bring down the price, to stay like before, on a high level and optimize price and cost optimization. So this was done in the last year, and now we are really happy. So it's again 50-60% of the savings comes out from the module, from the power we can give back to the customer.
Okay, and that's excellent.
Yeah.
So, Alina, you mentioned that you've done something in wind tunnel, and wind tunnel is something that is really plays a key in testing for trackers. You wanna expand on that?
I have experience in the wind tunnels. I have done like 5 years ago. So at that moment we were not using the two portrait. So I cannot tell you about this experience right now. I didn't do in the last years. That is when we are developing. I agree with Hans in some aspects that I think it depends. We cannot. There are several aspects that we need to consider when we decide to go for 1P or 2P. So right now, I don't think there is a straight answer to these questions because it will depend the area, will depend the location, installation, the maintenance. So for example, when the terrain is complicated due to rock, topographic, etc., the 2P configuration has 60% fewer piles than the 1P. So it affects to the risk and time of installation, but the ratio per modules per pile in the 2P is around 12-13 modules, while in 1P 6 to 7 modules. So if you have soils that that is very easy to go through, maybe have more piles is not a problem. But if you have grounds where there is a lot of pre-drilling required, or there are a lot of refusals in the piles for one reason or another, having the half of the piles could be a good deal and will make the 2P more favorable than on the execution side of the project. Then piles for 2P are fewer in number, but they are heavier in weight. So this is also something that we need to consider in the cost. So it's not an answer. I think you need to make calculations in cost. Also, as I was talking for Middle East, the conditions like the slopes with 2P slopes are going to be more easily addressed, north to south direction talking. This is because 2P are shorter rows than 1P, so they are able to follow undulations on the terrain. We need to consider also the ground cover ratio. 2P allows the installation of more modules per square meter than 1P. Maintenance, cleaning is faster and less expensive in 2P since there is better access with machinery to all the rows than in the case of double row in 1P. So the OPEX will differ from 2P to 1P. Performance of bifacial modules. 2P trackers height tends to be lower, which in turn means that the reflected radiation capture in lit areas is also lower. So you can see that there are several aspects that need to be considered when we decide to go for 1P to 2P. So I don't think there is now a straight answer to this question, and we should consider the specific characteristics of one solar plant, in my opinion.
Yeah, if you see the poll results, I think there's not really any specific. It's 30% saying yes, but the rest of them are a little on the fence, or just about 13% not on the fence. So from that perspective, Finn, do you have any thoughts on this?
Yep. Yes, for the application of the big models now, I think, yes, I agree with Hans. We reduced the cost on the structures about 70%, 15%. And that means the lower LCOE. At the same time, because of the increased size and weight of the models, the structural part faced a challenge. Yes, we that means to use larger cross-section talkie tube, the larger posts, yes, thicker, more thickness rails, and we are also developing a unique shaped talkie tube to maintain the maximum support for the models. With smaller cross-section to reduce the costs. And also there is always a difficult problem in the development of the trackers to ensure that the least amount of the material used in the same strands. So now the most important things for the structural part is to reduce, to use the least amount of the material to support the large format models. And also for the electrical part, I think we can use electrical linkage design compared to the traditional mechanical linkage without there is no transmission road. And I think it is with rapid installation, convenient to maintenance, and also with low consumption features. Yes, I think it can effectively reduce the labor cost during the installation. Also, it will provide a multiple protection, adapt to all kinds of strong wind conditions, I think.
Right. Okay. That's a good point. One thing that I've also seen in tracker technology is that you had in the past you had either a single block design where you had one big motor driving 20 rows, 40 rows, depending on the design and the length of the rows. And then you had the row design, which was like a single motor in the center and dampers at the end. And every row independent of each other. Now we've got linked rows. We've got 2 rows being linked to save on the electronics, maybe to optimize on the costing. And now we also have, within the single row, you have multiple drive points. So these are more innovations. So where do you think the industry is growing? I think, Hans, you might have a better view on that, given that you have a view across the board right now.
Yeah, maybe let me talk a little bit about what we are also evaluating and about our product developments. So we checked it very seriously. You mentioned let's say the dual row. We don't see a big benefit in the dual row. So the main important thing is that we have the amount of the strings per tracker. And you are right. When you have a single drive in the middle, and then you are limited with your wings on the left and the right side. I think the only one, I can mention my old company, IDEMATEC, the only one who really had on each post covered all the pressure because of the indirect drive, that was this company. And so I think, there's some companies coming with 2 or 3 motors. This is to let's say to copy a little bit this way, yeah. But this is one trend. The other trend is, and this is, I think we will follow this to go on longer rows, which is also better for cleaning, which is better for lowering the amount of the piers. And so this is our direction, yeah. And yeah, and at the end, as I mentioned, it's very easy to have a tracker design for the 210 modules. But it's not easy to have it on the commercial side, a very competitive and very low-cost tracker. So this is what we are focusing on. So cost reduction is the main driver, and of course, applying all the standards, applying the highest quality. This is a must. I mean, otherwise we are not the market leader. Yeah. And okay, your question was there's one tracker or two which may be one single and synchronize two motors. Or the other concept is an indirect drive, is more with sprocket wheels. Yeah, these are concepts, and we have to see if this is better in the cost price ratio or not.
Yes, but is it? I think that's one of my questions to you, Elena. Is that when you have, I mean, if you've done evaluation of trackers, you will see that there's a lot of aerodynamic flex and a lot of eccentric load that happens at different angles. Now, have you seen any kind of impact from having different kinds of technology? Have you worked on that?
I have analyzed, like when I was working with the wind loads, and we have analyzed different sizes at that moment. Obviously, bigger modules is translating bigger structure and heavier structure and cost. So always, like when you go for large modules, in this case we are talking of 2P, that is large. The savings that we can do from one side in terms of number of modules, in terms of area, that we will install more megawatts in the area, we need to consider the steel price, the steel weight that we will use, the piles, because when we will put more weight in the structure, we need to make longer piles. Longer piles sometimes means that the ramming will not be allowed, and we need to do drilling with concrete. So I think it's a multidisciplinary study. Like, we cannot say let's go for 2P or let's go for 1P. We need to decide with several parameters. In this case, Hans is working in the structure industry, in the structure company, so he knows this. But we need to consider several things, also civil works, cleaning.
Absolutely.
The wind loss, the tunnels, there is no constraints if you want to calculate for bigger structures. At the end, it's done with simulations and optimizations, and you can run the simulations with different parameters and check. This is something that the simulations will allow you to do. Like, you can make different thousands of configurations, optimizations. This is not the same for real wind tunnels. Real wind tunnels is what you need when you are going to do the solar plant. You need to validate the simulations with a real wind tunnel. So with real wind tunnel, you cannot work with the optimizations because it's more, you could, but it's more expensive. It will have a cost. So at the end, you don't optimize. But with the simulations, you can put several.
So when you say simulations, you mean CFD, or when you say wind? Yes, and when you say real wind tunnel, you mean boundary layer wind tunnel or the aerodynamic? I think a lot of people get confused.
With the pressure, yeah.
So there's a difference, right? There's a complete. These are two different wind tunnels. One is to check the aerodynamism, the flight capabilities, and the other is to check whether it'll actually stick around.
But in both you can calculate the wind loads. The only thing is the real wind tunnels. You need to validate the simulations, and the simulations is cheaper. Is with a computer, and you can play with different configurations. The real wind tunnel you need at the time that Hans I believe they know about this when they have to submit to the clients their structures, they need to be validated in a real wind tunnel, and to demonstrate that it can support the wind loss that for this specific area.
Absolutely. In fact, that when just to clarify what Elena means with real wind tunnel is, that means it's a boundary layer wind tunnel, because for trackers you need to make sure that you are checking turbulence results. That is also very important. just you checking the wind impact is not so much as the turbulence and all the things that factor when it's on the ground, right? So Finn, you want to take something on this?
Yeah, I have no more points to add here. I have similar views with Hans.
Yeah.
Yeah,
thank you, Finn.
You want to say something?
Because it's important. So we are doing our wind tunnel test very serious. So with CPP wind engineers, and of course we're doing the boundary level wind test already since we started in Next Tracker, and we do this physically at least for any product and any development we do in our Fremont test center. Yeah, this is a must. And we do for all our projects, we have the standards and the static wind tunnel study in parallel. Then we have the structural calculation, the module analysis, the wind flattering, everything we are doing per project. Yeah. So this is something which is very important. And this has nothing to do with 2P or 1P. Yeah? It has to do how reliable a tracker company or a racking company is. Yeah. So this is, I think it's really become a standard. But I really like to link this together with your first question. It would be great if this became a standard for everyone. Yeah. So this is what we are doing already for our customers.
Perfect. Thanks for that, Elena and Hans. I think that's a good answer. Now, what I think, okay, so I think we've come to that. Let me put up one more poll where we're talking about the large format modules, right? The ones which are 600 watt peak plus and the ones which are like 2.5, 3 meters, almost 3 meters. I put up a poll, so if the audience can so recently, while the poll is going on, recently what we've seen 700 watt peak modules, 710 watt peak, 750, and are the structures ready for those? Is there something that needs to be done? Is this something that can it be deployed today? What do you think, Finn?
I think. Sorry, I'm missing questions. Okay, can you repeat again?
Yeah, so basically now you have very large size modules which are 600 watt peak, 700 watt peak.
Yes.
And they have not really been tested out in the field for a long time. So are the tracker companies, the solar structure designers, have they already considered that? Is it ready to be deployed in the field? What do you feel?
Yes, I think so. Yes, I think so. In fact, there are already many projects using the models over 600 watts in utility scale projects. I think the solar multi-structure manufacturers, also the tracker manufacturers, already have done a lot of related tests. The CPP window tunnel tests and related certification also done a lot of innovation to adapt the models over 600 watts. A lot of new technical techniques, the innovation are used on the trackers, like the electrical linkage design, the multiple drive. Yes, I think so. We can already use the big large format models in the utility scale projects.
Right. Yeah, thanks. So I think we've got a result for the poll, and it seems that the majority, the feeling is that they are still not ready. I mean, that's the so you want to take that, Hans or Elena, on?
I think. Yeah, go Hans.
Okay. I mean, we will be never ready as long as we're not starting. So I think, yes, we are ready. Yeah, we are ready. But as long as you don't see some gigawatts installed, you might say, okay, it's maybe risky or whatever. But we did all participants, means the module suppliers, we in our test center, we did everything. And maybe let's give you another indicator. So I think all of the projects now in the Middle East, maybe let's say the PIF projects, the Rector projects coming, also the projects in the UAE, they will ask all the time also for the large size modules. So in our offer already, we offered some gigawatt here. Yeah. So this is for me a real indicator that the developers at least are going at the moment in parallel, and then at the end they will decide left or right. So this is the market, and we will see the next projects and the big projects coming with large modules here in the region.
Right, Elena.
So when you ask if it's safe, no, I mean, I believe all the structures can be designed and done in a safe way for any modules. It's always a matter of cost. How much will cost to make the structure safe for biggest modules? Because the same biggest modules means heavier structure, heavier steel. Then you need to do the calculations because you can optimize more the area. You will have more megawatts for a square meter. So it's always, you need to check the balance and how much it will cost. And also you need to think in the installation, because for the installation of smaller modules is faster and easier than when you give bigger modules, heavier modules. You need more people for the installation. You need to be more careful to lift these modules in the structure. So it will increase the timing of installation, that maybe reducing the cost of the megawatts per square meters. So you need to consider always this, because when you are in a rush to finalize plans, that usually is what is happening in Middle East, we need to finish faster. And in Middle East and right now in all the areas, we want the solar plant in a couple of months ready. This will increase the time, and you need people qualified to do this installation or train the people to do this installation. So it's not a big problem, not at all, but you need to consider also the time of installation.
Maybe, Linkage, may I add one point here?
Yeah, sure, go ahead.
Yeah, because maybe give you an example. We just signed a contract for projects, let's say for the price X, yeah, and we are now going, let's say, some weeks later for another project very similar for a price which is slightly higher, because we have a wind load of, let's say, 100, and we increase to 110 miles per hour. So this is the influence parameter which drives the price, because we are checking very serious, so we need more rails. And it's the same what Elena mentioned before, the soil. Yeah, then we have a project which is have a very soft soil, so the embedment depth is not 1.3 meter, is maybe 1.8 meter or 2 meters. Oh, that's clear that the price of such a BOS or the racking system is slightly higher than well optimized. So I mean, this is also something we have to see in what happened in the region. Yeah, you cannot all the time say yes, it's lower. So we have to see the parameter. It's corrosion, it's the wind, and it's the soil. Yeah, it's very important. And the fourth parameter, of course, is we are talking about the large size modules, which calls for some extra efforts in the racking system.
All right, thanks, Sam, for that. I think we're ending towards the end of the hour, so I'm going to have to put it out for Q&A. I'd like to discuss this much more. And thank you so much for all the valuable input that you all have given. It's really been a good conversation. So I'm going to put it out there. There are a few questions, so I'll ask the questions, and then any of the panelists can take a call on that. One of the questions here is, which wind speed, 3-second gust or 10-minute average, can be considered as adequate in GCC countries when designing trackers of fixed structure? So this is a question from Roberto Jimenez. Elena, you want to take a crack at that?
I cannot
Okay.
answer.
It's 45 meter to 53, something like this.
So you're saying up to 50 meter per second or 53 meter per second?
45 meter per second up to 53, 54 meter per second.
Okay, so that's a pretty high number, right? That's
Yes.
yeah. So 45.
Then it's an average. Yeah.
Yeah, I think there's one more question from Roberto, which is again, the values of basic wind speed are the values of basic wind speed in Dubai Wind Code and KSA SBC 301 good enough for the design? I think this is a very, very technical question. You need actually a steel structural expert on this.
We need to study this. We
So,
can have a look and reply later, because it's something that I don't know if my colleagues can reply, but you need to have a look, and it's not a straight answer.
Yeah, okay, if I can request the support to keep a list of the questions, we will try and reply to them in later by consulting with the teams.
Okay.
Right. And another question is, within the Middle East, do tracker manufacturers take into consideration above ground cabling on their structures? So this is for Finn and Hans.
Which kind of cabling?
Above ground cabling.
Ground cabling.
Above ground. I think maybe he's referring to the cabling which is on the piles rather than under the DC cabling and the AC cabling, which is not the AC, but I think the DC, which is you dig trenches.
Yeah, we have a DC cable management around our tube. This is it's a standard, and yeah, it's what we are doing here in the region. Yeah.
How about you, Finn?
I'm not sure about this. Maybe I need to study more. Asking our technical team.
Sure.
It's a standard.
Okay, there are more questions. So one of the questions pretty interesting is, can you integrate, this is from Saker in LinkedIn, can you integrate cleaning technologies in structure rather than relying on robots that would incur extra cost?
No, not yet. Maybe in the future.
At the end, it will be robots, the same, I believe. Even if it's integrated in the structure, it will be kind of robotic. So maybe
you have nozzles to blow air or something like that within the structure. But I think right now it's I think the robots are a completely different ballgame from structure manufacturing. So I think
sorry, Ritesh, it's a very good question, because maybe there are some ideas on the market. But first of all, the ideas have to be finished and communicated. The tracker supplier will adapt 100%. Yeah. So like what happened with the robot cleaning. So they developed a cleaning robot and we adapted. So it's not a problem to adapt it to the tracker. But first of all, I think an alternative solution has to be developed.
If you see, you were mentioning that you were working in a solar plant in 2018, how the robots developed in the last 3 years. It's very fast improvement. So maybe in 3 years, we are talking about the structure integrated with the robots and all together. We don't know where they are going, but it's true that the development was very fast and good for the cleaning system.
Maybe one comment I just saw in the last Friday in DEVA 5, and we discussed this robot cleaning. And the point is that not only the robot itself is important, also the brush and how to replace the brush. Yeah. So when we have a 1.2 kilometer, we just have one brush or one set of brush, and you can remove the brush very easy in seconds or minutes and replace the brush. This is also a very important factor for the O&M and the lowering the cost in the O&M. Yeah. So when you have something built in, then you have to build in for 1.2 kilometer. So I a little bit have no fantasy how we can do this, but only from the sense of the brush. Yeah. The brush is very important, not only the mechanics and the steel, also the brush.
Okay.
Yeah, especially here in Middle East, that the sun with the humidity together, sometimes it get stuck in the module.
Yep.
So, yeah.
Yeah, thanks. I think, those are very important points. I think one more question we've gotten from LinkedIn is the fact that any suggestions for robotic cleaning of bottom side of bifacial modules for PV structure design? So I think that is a question that is on everybody's mind. How do you clean the bottom of the modules? So anyone has any take on that?
Not really, from our point of view at the moment. I know this discussion, it's an important discussion, and we have to see the benefit. But I haven't seen a good idea so far.
All right. Elena?
No, I cannot say an improvement. You go through for manual cleaning if you want to clean this, but it's a long discussion with the robots, and I think it's something that need to be improved, like in some, like many other things in the solar industry. But still, we have points to everything is improving very fast and very good, but still we have points to improve.
I think one of the points that I've seen here is that people, I mean, there have been, I think, industry veterans saying that you need to clean it once every 6 months. You need to clean it once every year because it's on the bottom side. It doesn't get hit so much. But in the GCC, with the kind of sand, the dust devils that go around, I mean, if your tracker is pointing towards the east and the dust is coming in from the west, so that's going to stick to the back of the panel and going to create a lot of hotspots. So I think, Finn, you have any points on this?
Yes, I think it's very difficult to realize now. Of course, as you know, there is interference at the bottom of the models. Of course, there is a talkie tube under the models, so it's very hard to realize this cleaning the water button of the models. But I think the technology is developing, so I think it can be realized in the future.
Yeah, I think one of the big problems with having the back of the modules is you can't do a wet cleaning because you have the frame. So the frame will actually catch a lot of water over a period of time. So you would have hotspots. So if you see in the front of the module, you will have, there's a slight ridge on the aluminum frame. And there you'll have a lot of, if you do wet cleaning, you will have a lot of mineral deposits. And similarly, if you try water on the back of your panel, I think that is another case study that needs to be checked. And how to do dry cleaning, those are areas, I guess everybody, once you've got gigawatts of bifacial installed, some solution will come out. I have one more question from for Maqsood. He's asking, the price is very sensitive to the tilt angle. What would be the price increase in percentage for moving steps of 1 or 5 degrees? I think what he's mentioning here is not the tilt to east to west, but on the trackers normally are at zero. So you can actually tilt each one of them either 1 degree or 5 degrees. So you can get a lead. It's like fixed tilt. You tilt it towards the south a bit. So he wants to know what's the price increase and is it really viable from, I can take that answer. So basically in the past, we have done installations, but what tends to happen is when you tilt the angle of the panel, you need larger area because you've got to separate the panels. So your rows become longer, the ground coverage becomes much lower. The cost will also increase because you need to support different types of wind effects. So there is a significant cost aspect. It's easier just to put it at zero. The cost impact of additional steel versus the modules, they sort of play against each other. And you're better off using it at zero because those are tried and tested modules. There are solutions and those solutions work, but from an ease of installation, from an ease of usage, maintenance, long-term, then it's better to follow the standardization because over a period of time, that will be much more. You want to take that on, Hans or Elena, Finn?
Yeah, so we have not done any evaluations or development on this. Maybe there is a small benefit from the albedo and from the additional power. But like you mentioned, Ritesh, I think from the design what we have at the moment, and this is also a quasi-standard what we have in Nextracker or other companies, will be totally different than when you go in a certain angle, and right. especially from the wind sensitivity, it's a challenge, but we do not have any figures at the moment.
Okay, understood.
Sorry.
So we've got one more question from Dr. Hassan on LinkedIn. How efficient is using drones for cleaning modules? So while the name is drone based, our focus is on inspection. For cleaning modules, There are some solutions out there and they use a drone with a truck. I don't really have the numbers on that, but from what I understand, it all varies. So I don't have the answer for that. Anyone else has an answer on that?
No.
All right. So I think this is going to be a very specific question. This will have to be addressed to the people who are actually doing this activity. So currently we don't have that answer here. Maybe let us see if we can connect you with them, if there are any such going on.
I mean, it shows that we have a lot of maybe a lot or some new things are coming, yeah. But we are still working on the large size module, and we are working on again coming back to the world record in LCOE. I think we already had it so between 1.2 1.5 US dollar cent, and this is something we are working on to have the commercial background for all the gigawatt which will come in the region, yeah. And with the gigawatt, I'm really sure we will see another developments, yeah. So like the cleaning.
I agree with you. I think there's, I mean, we've got another 5 minutes, so maybe a couple of questions. So one question is that corrosion if corrosion is a big issue, would it be possible to use material different than steel, glass reinforced plastic? So has anyone ever considered that?
Yes, I have to say I'm a steel guy from my background, and I was so happy when we changed in 2011-12 everything from aluminium to steel. And I have to say we inherit this from automotive industry. So we have a high strength steel, we have the zinc magnesium and everything. And I think also from the environment point of view, this is really a very good direction, yeah, with the steel. I think it will last for some time that we have this steel structure, yeah, before we change it in different material. Also from the cost perspective, yeah.
Right. Alina, you have any thoughts on that? And Finn?
Everything can be studied at the end. I think the steel is working. I believe it's working well, and we have done a lot of improvements since we started to use steel. But why not to check other materials?
Absolutely. I think.
But what is important, Rita, sorry, what is important? Yeah, we are all talking about the green hydrogen. And we know that in Europe, we have the development that we have the first green steel, so we can substitute 95% of the CO2 from the steel. This is the future, so that we can say at the end, our tracker is made out of 100% green steel product. And believe me, steel is very close to be green compared to other products.
Yeah, I think that's important as well. So I think one other question is albedo enhancement, a membrane which reflects light back into the backside of the module. Do your structures shade the backside of the module? So from a tracker perspective, in the past when I was working with trackers, yes, you can put a membrane, but managing that membrane, managing the white reflection, the amount of sand, I mean, if you think about cleaning the modules and then you have to clean the membrane. So that is going to be a real nightmare. So reflection, you've got to work with what land you have. You can maybe paint it, but that's going to last you I mean, given the desert sand, locations which have like concrete, yes, but which have moving material, moving sand, all of that is going to be really, really tough to do that. And yes, there are structures, all the structures shade the backside of the module, but again, with bifacial, there is a certain limit under which there is a certain shading. If the shading is really dark, then only you have hotspots. But once you leave a certain gap, that's more than sufficient. You want to add anything? Anyone wants to add?
Oh, no, perfect. It's right.
Right. Okay. Anything else? I think there are a few other questions. I think, but nothing really so relevant that we can answer at this point in time. Okay, so I think we're also like a couple of minutes, so we can close this down. Thank you, everyone. Thanks to the panelists. Thanks to the organizers. Thanks for the audience for listening to us. And we're really happy that you could join us, and absolutely appreciate all the panelists for the kind of inputs they've given. Thank you so much. Really been a good discussion. Have a great day. Have a great week. Cheers, everyone.
Thank you. Bye.
Okay.
Thank you.
Cheers.